Uniform distribution. The continuous random variable x represents the error in millimetres made when a machine cuts piping to a target length. The distribution of x is rectangular, which also means uniform. It's just another name for it. Over the interval -5 to 5. So that means x can be anything in between -5 up to 5. It's equally likely to be anywhere in that gap. So that means it might cut the pipe 5 millimetres too short up to 5 millimetres too long. Okay, so our first question says, what's the probability x is less than -4.2? So we do this by just sketching our little rectangle that represents our set of numbers that we could have. And we just have to be below -4.2. So we've got to be right down at the bottom end there, somewhere in that little gap. So we need to know the probability of landing in there is the same thing as saying what's the area of that compared to the area of the whole thing, or what's the length of this little gap. I've drawn the arrow there compared to the length of the whole thing. So we'll do the length. So that length is a gap of 0.8, and the whole distance between start to end is 10. So our probability is going to be 0.8 over 10, which is 0.08, or you could express that as a fraction. Okay, the second question says, what's the probability that the modulus of x is less than 1.5? So they've given us it in symbols. They could equally say in words. They might say something like the magnitude of the error made is less than 1.5 millimetres. Okay, so remember you could have anything from 5 too short to 5 too long. Okay, what this question is saying is what's the probability we are less than 1.5 away from the target. So anywhere between -1.5 to +1.5, because that's what the modulus symbol is telling us. So once we've drawn our rectangle and we've identified what the question is, we can just do the same idea. What's this length? And that would be a length of 3 out of a total length of 10. So my probability would be 3 out of 10. Obviously I could put 0.3. Okay, question C. A supervisor checks a random sample of 10 lengths of piping cut by the machine. Find the probability that more than half of them are within 1.5 centimetres of the target length. Well, I hope it means 1.5 millimetres, because 1.5 centimetres doesn't seem right. Because it's not going to be 1.5 centimetres away. Let's go with millimetres. That's a weird one. Find the probability that more than half of them are within 1.5 millimetres of the target length. So we've worked out here the probability of being within 1.5 millimetres, because that's how I explained part B. We can be either 1.5 too short up to 1.5 too long. So we know the probability of this happening for one length of pipe, but what we've now got is 10 different lengths of pipe. So we have got 10 trials, and what we want is more than half of them need to be this success, which we're going to say a success is being within 1.5 millimetres. So we want more than half of them need to be classed as a success. So in this case, more than half, if we're talking about 10, is 6 or more. Okay, so when we have a question that is talking about a number of trials, how many successes, and you know the probability of a success, then this is a binomial question. So let's use a different letter, just because we've already used x up there. We've got 10 trials. The chance of this success being within 1.5 is 0.3. And we want the probability that we have 6 or more, so greater than or equal to 6. So So as soon as we transfer it into a binomial, we're now on discrete data. So we can't just ignore the equals. That's important now. We need to turn this around because remember, if we do BCD, that is going to find you the probability that x is less than or equal to something. So you have to turn this question around and make it be 1 minus the opposite. And the opposite would be getting rid of the 5 and lower, because you want to count the 6 here and anything more. So what you don't want to count is anything from 5 successors and below. Then you find your calculator and go into the binomial mode. Okay, so we want BCD whenever we're doing an inequality variable. So we want to put it in x is 5, n is 10, chance of success is 0.3, and it will give us the probability that we are going to be having 6 or more successors. Okay, I can just go into calculation and 1 minus answer, and it knows what answer we've just had on the stats mode, so you don't have to type it all in again. And then we can just round it however you want. That's 3 or 4 decimal places is lovely with probabilities.